Hello, my name is Dennis Knopfsinger, and I'm an instructor with Sunset Learning Institute. I have 32 years in the 802.11 Wi-Fi industry, and what I'd like to talk to you about in this webinar is understanding Cisco access point power settings. Over the years, Cisco has always had their controller, their wireless LAN controller, power settings presented to us as a power level 1 through 8. And when I say us, wireless engineers, right? And I would like to show some examples of a 2.4 gigahertz and a 5 gigahertz output showing the output of your access point power in dBm, but it also includes the level of 1 through 8. So dBm is what's most important, right? And so in this recording, I'd also like to give a demonstration using the Cisco Catalyst C9800 wireless LAN controller. The Cisco Catalyst 9800 is the current controller Cisco would prefer that you use in your wireless network. The Cisco Airspace wireless LAN controller has been around for a while, and it's tried and true, and it's a great controller. And there's a lot of them are still out there in production still. And so I would like to do a demonstration with the Airspace controller as well. Our wireless LAN controller wants to change our channel and our power for us, and that's great. And it does it on a 10-minute cycle. We call it fire or forget. So on a 10-minute cycle, the controller is calculated, should I change channel or power? No, forget it, and wait another 10 minutes. Or fire, do something about it. Well, in this recording, we're going to talk about power levels. So this first AP has a power level for the 2.4 gigahertz radio of a power level of 8. And 5 gigahertz radio has a power radio level of 3. This AP has a 2.4 gigahertz radio power level of 3 and a 5 gigahertz radio power of 1. And this AP has a 2.4 gigahertz radio power equaling 4, and the 5 gigahertz radio has a power level of 2. And so power level 1 through 8, how do I know what my power level really is? Because as wireless engineers, we're used to decibel milliwatt being the unit of measurement we go by, not 1 through 8. So it leaves us as wireless engineers scratching our head going, well, what really is our power level? So what do we have to do? We had to take a look at the data sheet. So I downloaded a data sheet from a Cisco AP, and that's what you're seeing here on the screen. Now, what I added here were these numbers 1 through 8. 1 through 8 for 2.4 gigahertz and 1 through 8 for 5 gigahertz. So what does 1 through 8 mean? Well, 1 means highest power, 23 dBm, 200 milliwatts. Well, if you step to a 2, that's 20 dBm, which is 100 milliwatts. If we step down to a 3, that's 17 dBm, which is 50 milliwatts. Now take note, if you drop from 200 to 100, you just cut your power in half. If you drop from 100 to 50 milliwatts, you just cut your power in half. And that's what we call a 3 decibel loss. So if you look at that step down from 1 through 8, my power is strongest at a 1 and lowest at an 8. Now on the right-hand side of this example, we have a 5 gigahertz radio. 23 dBm, number 1, highest power. 2, 20 dBm. And if you notice, it's going down from 1 to 8 to very low power. Now this example, very important to point this out, is from an FCC example. A regulatory domain, with access points being deployed in the United States. So if you are reviewing this video and you have access points deployed in different countries, your values 1 through 8 will be different. In these examples, I'd like to show you the first one. These are outputs from the controller. Yes, these are outputs from the controller where you actually interrogate a certain AP through command line, and you're asking, hey, what's your power level, right? So this first example is channel 36. Notice though, channel 36 has a total of 5, not 8 power levels, but 5. Well, that's because this is part of the 5 gigahertz uniband 1. Now, uniband 1 stands for Unlicensed National Information Infrastructure Band 1. It really just means we don't need a license. It's an unlicensed band, right? So this example is channel 36, which is the first channel in the band. So channel 36, channel 40, channel 44, and 48 uses these 5 power levels. The next example is from channel 52. Now, channel 52, if you take a look at this, we now have 6 power levels. And take notice that power level 1 on the top is a 15 dBm. Power level for this example is 17 dBm. So there's a little more power in this band. Well, this happens to be uniband 2, the Unlicensed National Information Infrastructure, uniband 2, and that's channel 52, shown here, 56, 60, and 64. These 4 channels share the same characteristics of having these 6 power levels. Up here, we have channel 100, and channel 100 has 6 power levels as well. And the 6 power levels are the same as the uniband 2. Well, this happens to be uniband 2E as extended. Oh, it has channel 100, 104, 108, 112, 116, 120, 124, 128, 132, 136, 140, and 144. Yes, sometimes these are referred to the dynamic frequency selection channels. And these are the channels that have the potential of interfering with radar. But that is channel 100 in this example. And these channels share the same 6 power levels. This last example at 5 gigahertz is channel 149. And take a note here. We have 8 power levels. And take a look at your power level for level 1. That's 23 dBm. This here is an example of uniband 3. Unlicensed National Information Infrastructure, uniband 3, channel 149 as shown here, channel 153, channel 157, and channel 161. And channel 165 gets a little special label of being part of the Industrial, Scientific, and Medical band, which is a non-licensed band as well. So they have more power. They definitely do. And so one of the things you want to take away from this is if you're having difficulty getting a signal at 5 gigahertz versus other APs, take a look to see what band channel they're on, because not all 5 gigahertz channels have the same power as defined by the regulatory domain. Now, how do you get outputs like this? How do you get this information from your own controller? Well, you might want to also take a look at 2.4 too, because I'm going to demonstrate in just a moment how do you get these kind of examples. Now, this one here is channel 1. This is 2.4 gigahertz. Notice that this output shows 8 power levels. Level 1 being 22 dBm. This happens to be channel 6. And channel 6 has the same 8 power levels. And then channel 11, remember channel 1 and channel 6 and channel 11 are non-overlapping channels. And by the way, all the channels, at least speaking for the United States, they all have the same power levels. This has 8 different power levels. So at 2.4 gigahertz, channel 1, channel 6, and channel 11 have the same 8 power levels, and they're all the same power levels. And here you can see your power in dBm in relationship to the power level number 1 through 8. So how do you get this information from your own controller? What I'd like to demonstrate is 2 controllers. The first one will be the Catalyst 9800 controller that runs the iOS XE. I'm showing it first because Cisco really would prefer that that's the controller family that you have in your enterprise. And the controller down here is the Airspace operating system. That'd be a 5520, an 8540, a 3504 for an example. And that operating system is great. But Cisco would prefer that your new deployments would have the Catalyst controller. So I'm going to go over these different commands. So at the controller prompt, you would type show AP name. Now pod 7 AP3 is the insert your AP name here. Mine happens to be in this demonstration pod 7 AP3. So show AP name pod 7 AP3 config .11 5 gigahertz. And this will show you the interface on the AP for 5 gigahertz only. And then there's a show AP name pod 7 AP3 config .11 2.4 gigahertz. Now, I will then show a demonstration on the Airspace operating system. Commands are close the same, but not quite. And so the command here is show AP config 802.11a AP and the name of your AP. And that will be for your 5 gigahertz. And then show AP config 811b AP. And that'll give an output of the power levels on your AP at 2.4 gigahertz. So let me bring my lab environment over to the screen. And the first thing I want to show you is the browser interface on this controller. So let me refresh my screen here. And I have a total of 1 AP on this controller. And when I click on the hyperlink on that little number 1 there, it takes me to the monitoring page. And this is showing my 5 gigahertz radio. There's many ways you can find this information out, but this is the fastest way. And you can see I have pod 7 AP3 on this controller, and I am looking currently at the 5 gigahertz radio. So when I scroll my screen here, I'm going to stop right here. You can see that my power level has a 1 there with an asterisk. And my channel has a 52 there with an asterisk. The asterisk means that the controller is in control. The controller is in control. They call it global, where the controller will make the channel and the power changes when it feels necessary on a 10-minute cycle. And so that's one way you can see what your power level is at and your channel. Through command line, what we're going to do, so I'm going to bring up a console access to this controller. Just one moment as I set that up. Now we have console access to our Catalyst controller, and the command will be show AP name pod 7 AP3 config .11 5 gigahertz. So show AP name pod 7 AP3, that'd be the name of your AP on your controller, and config .11 5 gigahertz. So when I press enter, I need to press enter just one more time for everything to fit on the screen. And what we see here is what my screenshots came from. My screenshots came from this here. So what you're seeing is the 6 power levels in dBm, and that my current power level is at a 1, which is full power, 17 dBm. And my current channel is 52. Let's go back to the browser interface in the controller. And let's look at the 2.4 gigahertz radio. So it's a simple click on the screen. We're seeing the same access point, but we're looking at the 2.4 gigahertz radio. So I'm going to scroll the screen here. And you can see my channel is 11 with the asterisk, meaning controlled by the controller. If the asterisk is missing, that means yourself or someone on your team has decided to set the channel manually or the power level manually. Now, what that means to you is that you told the controller you're not in charge of this AP. It has been statically set. So the asterisk means it's a global setting where the controller will change channel and power. So our power level here is showing a 1, right? Let's go back to the command line. One thing we have to do here in the command is just change the last part of that command to be 2.4 gigahertz. So show AP name pod 7-AP3 config .11 2.4 gigahertz. When I press enter, this is the output, but I need to press the space bar one more time. And what do we see now? That is the 2.4 gigahertz radio on this AP, 8 power levels. We see power level is currently at power level 1, and we see that's 22 dBm, and we're on channel 11. So that's an example of the Catalyst 9800 controller. Now let's take a look at the Airspace controller and take a look at these sample examples. We're going to take a look at the browser interface in this controller. And I'm going to click on the wireless tab up here at the top. And here's another AP I have on this controller. And what I would do here to see all that information that I would like to know about what channel and power level, there's a couple ways you can do it. But right now I'm going to come over here to where it says access points. And I'm going to click on the 802.11 A/N/AC. And there's my access point, but we are looking at the 5 gigahertz radio right now. So as I scroll across the screen, I'll stop here for a moment. You can see channel 52 has been assigned by the controller because there's an asterisk there, right? But keep scrolling, we will see that the power level here is at a 6 at the 2.4 gigahertz radio. So let's take a look at the command line interface of this controller. The command here for the Airspace operating system will be show apconfig 802 pod.11a, and the AP will be pod 7, and this one happens to be AP1. So show AP config, A11A, 5 gigahertz, pod 7, AP1. Now this output will require me to press the space bar 6 times. Based upon the font size I have and the screen size I have, it's 6 times, but it may be less for you. So let me just advance. And there we go. What we're seeing here is the transmit power. The transmit power level has 6 power levels at 5 gigahertz on this AP. Well, 1 through 6, you can see the power level mapped to the dBm value. And I need to press the space bar one more time to fit something else onto the screen. And here you can see our current transmit power level is a 6. So we know that's not very high power, it's lower power, right? And we do see the channel we're currently on is channel 52. So let's go back to the controller browser page. And take a look at the 2.4 gigahertz radio. So from the Airspace controller, Airspace operating system controller, I'm going to click on the 802.11b as in Bravo, G as in George, N as November link. That's our 2.4. You're looking at the same access point, but this time we're looking at the 2.4 gigahertz radio. So I'm going to scroll the screen over, stop right here. We can see that the channel is channel 11. Get all the way to the right here. And the power level for this AP is a power level of 8. So let's take a look at the command line on this controller. So the command is the same, except for, well, we have to change this to 802.11b as in Bravo and the AP's name. So this is pod 7 AP1. So the command is show AP config 802.11b as in Bravo, pod 7 AP1, and I will have to press the space bar about 6 times here. And there we are. For 2.4 gigahertz on this AP, we have 8 power settings. We have 8 power settings shown here. And I have to press space bar one more time. So you can see that our current power level is an 8, and our current channel is channel 11. So that is how you can find out in dBm what power level your AP is set to. Not 1 through 8, but now we can kind of use a secret decoder ring to determine what 1 through 8 really means. But as engineers, dBm is what we're looking for. And we really notice here that 2.4 gigahertz, the power level is the same on all channels 1 and channel 6 and channel 11. That'd be true in all the 2.4 gigahertz channels using my FCC regulatory domain AP. But we saw that the 5 gigahertz, well, not all the channels have the same power levels. So if you're investigating a signal problem on an AP where some APs don't have any issues, you might find that, well, the channel the AP is on, well, it has a lower power level for that band. So you could change that AP's channel to have more power, possibly, right? But that way you would really know. Now, this is very helpful when you have APs or controller from different regulatory domains, because different regulatory domains, access points will have software called country code that will prevent the AP from using illegal channel and power levels in that country. So the examples I'm showing here are all from the FCC, but yours might be different if you're viewing this recording and you live in a different regulatory domain. Okay. Thank you for your time in viewing this video. You can send emails to dennisnofsinger@sunsetlearning.com, and I appreciate your time.